First things first, let's import PixelFlow as PF. The beauty of PixelFlow is that it has tons of ready-to-use functions and methods for computer vision tasks. One of them is the media class for handling video files. It uses lazy loading for video frames, so you don't have to worry about memory consumption, and you can easily iterate over frames one by one. So let me create a media object here. I'll pass the path to my video file, which is traffic.mp4s. Now, let me show you something interesting. If I print video.info, we can see all the metadata about this video. Let's check what we have. As you can see, we get the resolution 2200 by 2000, the FPS is 30, we have 750 total frames, and the duration is 25 seconds. This information is crucial, especially the FPS, because we'll need it later when we're writing our output video. Now, to process this video, I can iterate through the frames with a simple for loop. So I'll write for frame in video.frames, and this frames property is actually a generator that yields frames on demand, which means it doesn't load the entire video into memory at once. Perfect for processing large video files. PixelFlow also provides two essential functions that I want to mention. We have showFrame function for displaying frames in a window, and writeFrame function for saving our processed frames. I'll be using writeFrame at the end to save our output. Alright, now let's integrate a vision AI model. I'm going to import YOLO from Ultralytics. And now I'll initialize my model. I'm using YOLOv11 Large for this example because it gives us better accuracy. Once we have our model ready, let me run inference on our frame. So I'll write Ultralytics results equals model frame. This is the standard Ultralytics way to process frames. Now here's where PixelFlow really shines. We need to convert these Ultralytics results to PixelFlow's unified format. So I'll use pf_detections.fromUltralytics and pass our Ultralytics results. This conversion is what makes PixelFlow framework independent. Whether you're using Detectron 2, YOLO, Transformers, or SAM, PixelFlow can work with them all. Perfect. Now I have my detections in PixelFlow format, so let's start annotating. The first thing I want to do is draw bounding boxes. For this, I'll use the box function from PixelFlow's Annotate module. I need to pass the frame and the results. And just like that, we have bounding boxes on our detected objects. Now let's add labels to see what objects we're detecting. I'll use the label function. Again, I need to pass the frame and results. Beautiful. Now we can see the class names and confidence scores. Looking at the results, you might notice the model is a bit confused. It's detecting cars, buses, and trucks inconsistently. Some vehicles are labeled as car, some as bus, some as truck. Let me fix this with PixelFlow's class remapping feature. Since I know Ultralytics uses COCO classes, car is class 2, motorcycle is 3, bus is 5, and truck is class 7, I'm going to remap all of these to class 2, so all vehicles will be unified as car. Let me use the remap class IDs method. I'll pass a list of the classes I want to remap, so 3, 5, and 7, and map them to 2. There we go. Now all vehicles are consistently labeled. Next, I notice we're detecting some people in the frame, but for this demo, I only want to focus on vehicles. So let me filter out everything except cars. I'll use the filter by class ID method and pass class 2. Perfect. Now we only have vehicle detections. I'm also seeing some flickering with low confidence detections, especially on distant objects. Let me filter by confidence to clean this up. I'll use filter by confidence method and set a threshold of 0.6. I can see there's still some noise from very small detections. Let me filter by size. I'll use filter by size with a minimum area of 4200 pixels squared, which is roughly 65 by 65 pixels. This should remove those tiny, unreliable detections. Now, PixelFlow offers many more annotation options. Let me show you some creative visualizations. First, let's add a grid overlay to better visualize the detection regions. I'll use the grid overlay function. I need to pass the frame and results. This creates a nice grid pattern that helps segment the image. This is a smart grid, which I will explain in future videos. How about adding some semi-transparent filled boxes for a modern look? I'll use the filled box function. I need to pass frame, results, and I can also specify the opacity. Let's set it to 0.3 for a nice transparent effect. Oh, and for the labels, let me reposition them. By default, they appear at the top left, but I can change that. I'll use the label function again, but this time I'll add a position parameter and set it to bottom right. See how the labels moved? You can position them anywhere, top left, top center, bottom right, center, whatever works for your use case. And there you have it. We built a complete computer vision pipeline with PixelFlow, from loading video to running AI models to filtering and annotating results, all with clean, simple code. If you have any questions or feature requests, please don't hesitate to reach out in the comments below.